A CT scanner at first is just a real-time X-ray, and that alone gives you the capability to look at an object live time to see the internal structure. And if you don't like the current view, you rotate it a little bit and get a different view, which is different from conventional X-rays where you have a single orientation. You take the photo, you look at it, then you reposition it. This, you're looking at it live time, and you can zoom in, zoom out, focus, change the intensity. So it's a really powerful tool in that aspect. And then the rotation is that when you take a scan at revolutions or positions, you could then put all of those X-rays together and form a model. So you get a complete image of the object. You know, the standard kind of use for the CT scan is to look at an object that you want to disassemble. But prior to disassembly, you want to take a look at the internal structure to see if you're going to change anything in any way. So it's basically a way to memorialize the structure internally before you take it apart and possibly incur damage upon disassembly.
So whenever you dissect a piece, you always run into a risk of destroying something that you want later. And if you don't know what's inside of it, you're going in blind, you're just guessing, and you're hoping to get the right result, and you're hoping to not destroy anything that's important to the evidence itself. And without being able to look inside of it first, you're just kind of going in blind. So with something like this, it really helps us identify the location of things to know what not to cut around or where to cut to. For example, we did a project where we had a lot of stators, and these stators are essentially these big long cylinders that have wire wraps, and there's probably 150 wraps in each of these segments, and there's like 5 segments around this object, and it's all potted in epoxy plastic, and it's got this metal frame around it. So the customer, the client, knew that there was something wrong in there. They didn't really know what it was that was wrong. They knew that they were having some shorting issues, but they weren't able to really figure out well what the issue was with those parts. So in a traditional standpoint, the way to get to that is to cut it, polish it, see if you see something. But the problem with that is when you cut and polish something, you only get one singular plane. So you get one plane that you get to cut, and then if you wanted to cut something here, I mean, you kind of can, but as you keep on cutting these pieces, you can't go in there infinitely and keep changing where you want to look at something, where you can with the CT scan. In this example, we found some wires that were spooled. They kind of had like a little bit of a loop to them. Some of them kind of ran around. Some of them had some kinks or pulled tight. And these were all things that it would have been just blind luck to be able to land on them. So it really gave us the ability to go in there and look at this and say, okay, here's this exact piece. Now I can know exactly where it's at in this piece. We can actually take some identifying marks to figure out what the rotation angle is, cut it out, cut right to that location, polish it in these really strange planes that probably wouldn't have been something someone would have expected to polish, and polish right to them and take great photographs of them. And it's not even completely feasible to be able to do something like that, because there are going to be random errors that happen not in the same place. They're at random locations, random type of errors, and there's no way you could do that by hand. There's no other way to do that without this sort of process.
There's one in particular that comes to mind where it was a product liability matter, and we were defending the manufacturer of a plastic guard. And one of the allegations against the defense was that they didn't screw in with a metal screw properly into this plastic guard, which would have secured it to the device. During the initial examination, we really couldn't see inside the hole very well to see if there were marks from the original threading of the screw. We were told that we had 2 hours to look at it, and then we put it to the CT scanner, and within 45 minutes we had a complete picture of that bore. And we were able to show that there were thread marks or threads cut in to this plastic piece from this metal screw. And then we also had enough time, because it only took 45 minutes, we had enough time to actually scan the screw, and so we could actually mate up the screw into the threaded plastic piece, and there was no way we could have done that without the CT scanner. And the report really came out really nice, because it allowed us to take slices through the plastic piece and then mate it with the metal piece. The coincidence of the features was right on, so it was basically a slam dunk.